Hello all. In this video, we are going to do the practice problems example 98 to 101. So these are examples I assigned in class for you to practice. Hopefully you all did it. So we are going to look at the solutions together. All right, so let's get started. So example 98. So we let fx to be x to the fourth power minus 8x squared minus 1. So this is my function f. I want to find the interval such that f is decreasing or increasing. So that is part A. So part A. Well, we have the function f. Of course, in order to find the interval of decreasing or increasing, we need the first derivative. So I'm going to take the derivative of the function f. Well, that will give me 4x cubed minus 16x. Well, you can factor it. So this is going to be 4x times x squared minus 4. Well, x squared minus 4 is the one that we can factor. So we have 4x times x minus 2 times x plus 2. This is amazing. So it is nice and clean now. So we can look at the critical number. So f prime x equal to 0 when x equal to negative 2, 0, and 2, right? Well, these are our critical number for this problem. All right, once you have all critical numbers, so we can look at the interval. So this is going to be negative 2, 0, and 2. All right, we want to look at the behavior of f prime. So when x greater than 2, so what happened? So when x greater than 2, you can plug in the number that is bigger than 2 into the function f prime, and then you will see that you get a positive thing, right? This is positive. Well, the number between 0 and 2, so if you plug in any number into the function f prime, so you're going to get negative thing. This you're going to get plus, this you're going to get minus. All right. Well, for those of you who want to memorize the technique, plus minus, uh, remember that this technique only works when you have a linear factor, right? So if you have something that is not a linear factor, this technique will not work. For example, if you see something like f prime x, let's say equal to x minus 5 to the 10 power times x plus 1 to the 25 power, for example, something like that. Well, even you know that the root is going to be negative 1 and 5. However, you cannot just use the plus minus, just swap it as a linear factor because your power here is not 1. So this is what I mean by linear factor. So the best way to figure out the sign of f prime, you just need to pick one number on that interval and plug it into f prime. That is the best way to do it. All right, next we are going to uh, answer part A now. So this is going to be the interval of increasing. So you just answer the one that you see the positive side, which is going to be negative 2 to 0, union to infinity, and then the interval of decreasing. This is the one that you see the negative side, which is going to be negative infinity to negative 2, union 0 to 2. So this is part A. So easy. All right, part B, we want to find all local maximum and local minimum. For sure, the f prime here gonna help us to figure out the local max and local min. So for part B, I'm gonna copy the f prime from part A. So this is part B. For part B, so we have three critical points, which is going to be -2, 0, and 2. So at x equal to -2, you can see that the sign uh, swap from negative to positive. So this is actually the local minimum, right? Because the function is decreasing on the left of -2, and the function is increasing on the right of -2, which means actually at x equal to -2, this is local min. So the same thing with at x equal to 2, this is going to be your local min. So the at x equal to 0, this is your local max, because the sign changed from plus to minus. All right, so I'm gonna compute f -2, f0, and f2. So f -2, this is going to be 16 minus 32, right? Because 8 times 4 is 32, and then minus 1. So this is going to be -17. And then f0, this is going to be 0 plus 0 minus 1. So this is -1. And also f2, this is going to be 16 minus 32 minus 1. So this is negative 17. Well, we have f -2 equal to -17. F of 0 is -1. And f of 2 is -17. All right, which we can conclude the answer now. So all local maximum point, this is going to be x equal to 0, y equal to -1. And all local minimum point, this is going to be -2, -17, and to -17. All right, well, simple, right? All right, next we are going to look at example 99. So now we move from local minimum to absolute minimum and absolute maximum. So we want to find absolute maximum and absolute minimum of the function f on the interval -1 to 4. So we're gonna start by, of course, take the derivative of f. So, well, with the given function that I highlight in green, so when I take the first derivative, so I get 12x cubed plus 48x squared plus 36x, right? And then I can pull out 12x because we have 12 and x in in the polynomial, so we can factor it out. This is going to be x squared plus 4x plus 3. All right, sounds good. Next, we are going to have 12x times x plus 1 and x plus 3. Well, we are master in factoring, right? Next, I have f prime now. So I can look at my critical point. So f prime x is equal to 0 when x equal to 0, -1, and -3. All right. This is my critical number. So once you get your critical numbers here, so you can look at whoa, this is absolute max and absolute min. So all we need is just we need to include the endpoints, and then you just compare all the values. That's all you need. So let's look at the critical point. Critical numbers and the endpoint. So you can see that we want to find the absolute max and absolute min on the interval -1 to 4. So the interval -1 to 4 is here. So your endpoint is going to be -1, and another endpoint is going to be x equal to 4. So you have to include these two x values to be your candidate that you're going to get absolute max and absolute min. So now your critical numbers is going to be when x equal to 0. So this is going to be your critical number. Right? However, x equal to -1, this is the same x value with the endpoint. So, well, we already included because it is an endpoint. And x equal to -3, we can throw away because this is outside our interested interval. So we can throw away x equal to -3. So now we have 3 candidates that will give you absolute max or absolute min. So we just need to compare them. So f of 0, f of -1, and f of 4. Alright, so f of 0, this is going to be 3 times 0 to the 4th power plus 16, 0 cubed minus 18, 0 square. Boom, boom, boom. So this is 0, right? And then for -1, you get 3 times 1 plus 16 times -1 plus 18 times 1. So this is going to be 5. And then the last one, f of 4. This is going to be 3 times 4 to the 4th power plus 16 x, which is 4, right? This is 4 cubed and then plus 18, 4 square. Wow, this is going to be a big number. So 4 cubed, no, 4 raised to the 4th power, this is 256, and then times 3, so this is 768 plus 16 times 4 times 4 times 4, which is going to be 1024, right? And then plus 18 times 4 times 4, which is going to be 288. Wow, this is a big number. And then 288 plus 768 plus 1024. This is going to be 2080. Well, that means your absolute maximum. Well, to sum up, your absolute maximum, well, is attained at, well, we just compare the value of y. So you have 0, 5, and 2080. So that means your maximum is at x equal to 4, y equal to 2080. Well, and also your absolute minimum. Well, this is attained at x equal to 0, y equal to 0. Alright, that is how you conclude example 99. So not hard at all, right? So example 100. So let's look at the trigonometry one. So we have sine square x minus square root 3 times sine x on the interval 0 to pi. So what is going to be our absolute max and absolute min? Here we go. So we're gonna differentiate f first. So I have 2 times sine x, and then by the chain rule I have cosine x, and then minus square root 3, differentiate sine, get cosine. Alright, so for sure I see cosine x, so I can factor out. So I have 2 sine x minus square root 3 here, and then you can see that f prime x equal to 0 when cosine x equal to 0, or 2 times sine x minus 3, minus square root 3. This is going to be 0, right? Because, well, the product of two numbers is going to be 0 when either of them is 0, right? So for cosine x equal to 0, so what is going to be your answer here? So that means x equal to pi over 2, right? Well, it's going to be only one solution because we fixed the interval to be 0 to pi. So we just need the x value that lies in the interval 0 to pi. So the same thing with the later one. So 2 sine x minus square root 3 equal to 0. So this means sine x equal to square root 3 over 2. Well, are there any angles that solve sine x equal to square root 3 over 2? So for sure, the first one is going to be pi over 3. Right? The next one, this is going to be 2 pi over 3. Right? Because this is because when you solve the trigonometric equations, you have to be careful about the solution because sine function is positive in the first quadrant and the second quadrant. So you have to answer for x here. All right, so you have three candidates for absolute max. So now it's time to compare. So you compute. So the first one is f pi over 2. The second one is f pi over 3. The third one is f2 pi over 3. The fourth one is going to be f0, and the fifth one is f pi. So the last two this is going to be our endpoint. So we have to include our endpoint as well when we look at the absolute max and absolute min. So this one I compute it to be sine square pi over 2 minus square root 3 sine pi over 2. Sine pi over 2 is 1, so it's going to be 1 minus square root 3. Right? And square root 3, this is about 1.73. So this is negative 0.73. All right, save it for later. Next, f pi over 3. So we're going to do the same thing. We just change pi over 2 to pi over 3. So sine pi over 3, this is square root 3 over 2, which you square it, so you get 3 over 4. And then minus square root 3 times sine pi over 3, which is square root 3 over 2. So at the end, you get 3 over 4 minus 3 over 2. This is going to be negative 0.75. And then f2 pi over 3. All right, so this is the one that, here we go, you have the same answer with f pi over 3 because, well, sine pi over 3 and sine 2 pi over 3, they give you the same value. So this is negative 0.75. Well, let's look at the endpoint. So the endpoint is going to be f0 and f pi. So f0 is sine square 0 minus square root 3 sine 0. Well, it's actually 0. And then the last one, f pi as well. So sine square pi minus square root 3 sine pi. Well, this is actually 0 as well. All right, so now to conclusion. So what is going to be our absolute max value and absolute min value? So absolute max value, this is going to be 0, right? Because 0 is the biggest one. Compare the 5 numbers here. And also the absolute minimum one. This is going to be negative 0.75. All right. Example 101. So let's look at the word problems. So this could be a good modeling in biology. So suppose that the population in thousands of a certain kind of insects after t months is given by the function pt equal to psi 2t minus t plus 10, where t less than 10. Well, let's find the minimum and maximum population in the first 2 months. So that means we want to find the absolute max and absolute min on the interval 0 to 2, right? Because we just need the absolute max and absolute min in the first 2 months. So first, we're gonna differentiate, of course. So differentiate sine, you get cosine. Well, but by the chain rule, you have to, and then differentiate negative p, you get -1. All right, and then that constant differentiate, you get 0. So you can see that p palm t, this is going to be 0 if cosine 2t equal to 1/2. Well, cosine 2t equal to 1/2 mean 2t equal to pi over 3, right? And that means just the t equal to pi over 6. Well, this is your critical point. So, well, to make sure that we have all critical points and all critical numbers, well, let's take a step back to look at the equation here. So we have cosine 2t equal to 1/2. Actually, when you solve for trigonometric equations, so you could have more than one solution, right? Because there are so many angles that when you take cosine, you get 1/2. So actually, you have pi over 3. And because cosine is positive in quadrant 1 and quadrant 4, so you have pi over 3. And the next one is 5 pi over 3. And the next one is going to be 7 pi over 3, and so on. So when you divide it by 2, this is going to be 5 pi over 6, and then 7 pi over 6, and so on. So do we need to include all solution here? So we're going to look at the interval that we are interested in. So we are interested in 0 to 2. So of course, pi over 6 is in uh, the interval 0 to 2. However, if you look at 5 pi over 6, this is 5 times pi, which is 3.14. So on the numerator, this is about 15. And then over 6, this is already over 2. So which means this is outside the interval 0 to 2. So we are not interested in this t, and so on. So we just only need to include t equal to pi over 6 to be our candidate for absolute max and absolute min. So we compute f pi over 6. This is our candidate from the first derivative. And then we include the endpoint, which is f0 and f2. All right. F pi over 6 is what? So sine 2 times pi over 6 minus pi over 6 plus 10. Here we have sine 2 times 0 minus 0 plus 10. And then we have sine 2 times 2 minus 2 plus 10. All right, let me fix the notation a little bit. This is not f. This must be function p. Sorry. All right, this is p, this is p, this is p. All right. Well, let's start from the easy one. So p0, so you get 10, right? Because sine 0 is 0, and 0 plus 10 is 10. So p2, so we have sine of 4, which is given as negative 0.07568. So negative 0.7568, and then plus 8. All right, that is not hard to compute. So it's gonna be 8 minus 0.7568, which is 7.2432. right? The last one, p pi over 6, this is sine pi over 3. Sine pi over 3 is square root 3 over 2, and then minus pi over 6, and then plus 10. So square root 3, this is 1.73 approximately over 2 minus pi over 6, which is uh, about 3.14 over 6, and then plus 10. So I'm going to compute this thing. So 1.73 over 2, this is 0.865 approximately, and then minus 3.14 divided by 6, which is 0.523, and then plus 10. So the answer is going to be 10.865 minus 0.523. This is 10.342. So to conclude this thing, so you're going to have the absolute maximum. This is going to be 10.342 unit. The unit here is in thousands, and then the absolute minimum, this is going to be 7.2432. This is attained when x equal to 2. All right, so this is the example on finding absolute max and absolute min inverse problems. So for those of you who are concerned about using calculator, I want to say it again on this video clip that, well, no calculator is allowed on the exam, so you cannot use the calculator. However, on the real exam problem, the number that we will give you to solve, those are going to be the number that is easy to compute. And that is all for this video clip. So see you again in the next video.